Welcome, data people. We are Zuma. My name is Matt, and this is Data for Good. This podcast is brought to you by Zuma. Zuma is a dedicated recruitment company for senior data, insights, and analytics professionals, connecting you with Berlin's most influential companies. The Data for Good podcast is for the world of data analytics and engineering, giving you access to the thoughts and opinions of Berlin's most successful data people. Today, we are joined by Pascal Holy, data architect at Encavis. Now, we're looking forward to this. Pascal is going to inform us about areas of data that are underestimated, as well as single source of truth and real-time data. And it is self-proclaimed that data is his mojo. Pascal, welcome. How are you?
Hey, great to be here, Matt. I'm great. Just had a long weekend, so I'm fully refreshed and ready to take on the data world again.
Fantastic. So yeah, October is here already. How are you and the team set up for Q4 and looking towards 2023?
Yeah, I think we're doing good. We had a big restructuring of our data infrastructure in the past, but that is now almost complete. So we are getting the first feedback from our users, which is just euphoric. So we are happy to continue with that and get more and more feedback and insights into the data that we have.
Great to hear. I can hear your passion about it already, which sets us up for a great podcast, a great episode. So, an area that I know you love to talk about. Let's talk SQL. Now, it's not an area that most would consider as necessarily sexy. So, what is it about SQL that you think makes it maybe not as desirable to master as other areas?
I mean, I think, well, first of all, it's the descriptive language. So you don't really say how to get something, but only what exactly it is that you want, right? You describe the data that you want, and the database gives you the data that you want. So for most people, especially coming from the software engineering, where they really only used SQL to get the data out of the database, it's seen as this simple select from, and that's it, right? And that's also what you start with when you learn SQL. I think a lot of people might be coming from some online courses where they've seen SQL and just thought it's a really simple language. But that also is the beauty of it, right? It's really easy also for non-technical people to learn the keywords that you need and to get the data that they want. But what people don't think about is that someone has to design the tables so that makes it really easy to query the data, right? That if you're in a company, you probably have hundreds of tables, right? So the first question that comes to when someone comes with you with a business question is, where do I find the data, right? You need to search for the tables. So the tables have to be named correctly. They have to be up to date all the time. And the columns have to be also meaningful named. And yeah, you need probably also some domain knowledge to understand what it is that the data actually tries to tell you.
Okay. So you're a software engineer. You're thinking of moving towards data and specialize in this area. You look at it and you think, oh, this is quite straightforward. I don't need to focus on it too much. What would you present to them to make them dig a little deeper and really push their learning?
Yeah, I think a great tool that has developed over really only the last couple of years, but is now almost an industry standard, is a DBT, the data build tool, which is a tool that kind of generates a bit of SQL for you. So instead of referring to the table names where you select from, you basically only put a string that then references the names of the files that generate these tables. And what this gives you is a kind of an automated data lineage, because then you can the tool really draws a graph for you where you can see this column from this table derived from this column in this table, and this is from this. So you really see the data flow through the whole whole database, which gives you, first of all, a better understanding of these hundreds of tables that you have, right? Because suddenly you see what the connection is between these tables, and you can also update things more easily, because when you're updating some logic and the raw definitions of the data, and this data or the transformations of it, they need to pass through all of the different transformation steps that you have. Usually you set up a data warehouse in different layers. So you have like a data layer where it's really just the raw data kind of unfolded and cleaned kind of, but then you have a kind of an object layer where you create different business objects out of the data and model the relations between them. And in the end, you have a business layer where things are named properly, not really how a data engineer would understand the data, but more how a business person would understand the data. So they are named nicely and have the proper formatting already. So it's consumable. The data is consumable for business people in the business layer. But to be able to have the data in the business layer needs to be transformed all the way. And that also is something that DBT helps you, because what you can do there is just change something in any table and then update going forward all the tables that referenced this data point. That makes it really easy to do changes, even very low level changes, and have everything be up to date with these changes with just a simple command.
Okay. So the introduction of DBT, is this helping the data consumers more, or the data producers and the data engineers?
It's the data producers, I would say. As an end user, you don't really see it at all. You just see that all your tables are always up to date and well tested. But as a data engineer, it helps you to write more elegant code, I would say, because you can also write loops, right? Loop is a very fundamental thing for software engineers, but in SQL, it was never really possible. But with DBT, you can write a little statement at the top that says, give me all unique values from this column. And then you can loop over these values and do something with it, right? The most dominant example for this would be currencies, right? You have a table with currencies. So you get all the currencies that you have. And then you create, for each of these currencies, you create a new column where you then get the exchange rate somewhere from, and then you have automatically a column for each currency if you want that. And if you add a new currency because your business has expanded to a new country, then you just need to add it to your currency table and rerun the model. It will automatically create the new column for you.
Okay. So it sounds like DBT is there to enhance SQL as opposed to replace.
Exactly, yeah. The language is almost the same. There are just a couple more keywords that you need to learn, and you have more functions. As I said, you have ifs, if-else statements, and loops that you can use to generate the SQL code.
And SQL's been the bread and butter for many, many years.
Yeah, it's been around since forever almost, right? It's based on relational algebra, and also databases these days. They're so advanced that while you write very simple queries, it will do lots of complicated computations to perform the actual calculations as efficient as possible.
Where do you see it next? So how is it going to improve itself, better itself moving forward to cope with the even higher demands of data that we're going to see in the near future?
Yeah, I think it should really just become more known, right? Even outside of the IT department of any company, right? Because a dashboard can only get you so far, right? And if you for every business question that you have, you need a new dashboard, then this kind of hinders your speed, right? When you want to have fast answers to your questions to derive business insights from, then you should be able to answer these questions with SQL. So what I hope is that the IT departments in this world will give some schooling lessons, right, to the business people for them to answer their questions on their own, or use they also developed a couple of tools over the years where that kind of it generates the SQL for you, right, where you only say I want this and this and this column grouped by this, and then I think Looker is a big example of that, where it has a nice user interface. You just click on the columns you want, and then it generates the SQL for you, which is also a great starting point, right? For people that are not that comfortable with it, they can just look at the query that was generated and modify it to their needs.
Sounds like there's a big push for self-service data with all these tools that are being introduced.
Yeah, I think data engineers are very high in demand at the moment. And the more time you can save from them, the more value they can create further on. Because data engineers should not really answer business questions. That's more what a data analyst does. Data engineers should build the pipelines, right, that streamline the data from the source to a format that can then be consumed.
We're seeing the rise of the analytics engineer. It's the mix between the analyst and the engineer. Do you see this as a future-proof position, or is it just a little bit relevant the way that data's functioning at the moment?
I think it also came with the rise of DBT. So analytics engineer and DBT is well connected. So they should really leverage all the tools that DBT gives you. There's more that we haven't talked about, like tests. You can write tests for your data suddenly that then are automatically run for you. And also version controlling. This is a big part of DBT that the analytics engineers of this world should really embrace to get to a higher data quality and to have not just break tables all the time, right? If you have a dev environment, you can do whatever you want, but all your data consumers should run in the production world where tables are a lot more stable and don't fail all the time, because of course you need to develop new features and add things and change things, but you should do this but you should tell people before you do so, which you can't do with a production environment. So I think analytics engineers just all the procedures and processes that have developed for software engineering over the past now applied to data engineering.
Would we be safe to say that the analytics engineer is the new DevOps engineer, the new full stack engineer, that are very, very powerful and useful in some environments and situations, but it's not the answer to all?
Yeah, I think you still need both. I think it just has developed as a little parallel to the data engineer, so that the data engineer has more time for what they want to do is to also to connect more data sources. But the more and more data sources you have, the more kind of data quality checks you need, and this is what the analytics engineer then can do. And also, as I said, to not break things all the time.
You make a great point, and data sources and data quality. A big factor for this is a single source of truth. So we've spoken about this previously, but a single source of truth, what is this?
It's essentially just means that all the company's data resides in one point, right? If someone changes some aspect, then it should all instantly be propagated to everyone in the company, right? That's kind of what you lose when you have where a lot of people are coming from, is Excel sheets, right? A lot of companies' data, even today, is just in Excel sheets, and they might be hosted somewhere, but it happens really easily that someone changes something in an Excel sheet, and someone opens an old version of that Excel sheet, and then you lose the single source of truth, right? Then someone uses outdated information, and that's just what the single source of truth prevents you from doing, because everyone accesses the data in one point. That is often a data warehouse or a data lake. And that's just the one place where everyone works together to kind of have or form the whole company's data insights in.
So why is it so important? What are the effects, the negative effects, and the areas of the biggest gain from having this single source of truth?
Yeah, it's essentially, if you don't have it, you might work with outdated information, which can cause tremendous damage to your company if you don't even know what is happening at the moment. And also if you report on it, right? If you report to your stakeholders with data that is not up to date, because not everyone has all the data, then that can lead to wrong decisions, going down the wrong path with your business, which can really cause the business to fail.
And from a business perspective, how can a company ensure that we are working towards this perfect source of data?
Yeah, I mean, what you need is a data team, right? You need to set up a data team that gathers all data that you have. Probably you have some systems like an ERP tool or a CRM tool where your customers' data is in. But then this is not connected to your internal system for managing projects, for example. And the data team's first task would then be to extract the data from both of these systems, combines them in a single source of truth, which is a really hard task, right? Because it requires a lot of business knowledge as well, for what does this point mean? Where is what data coming from? Because a lot of companies, this has evolved over long decades, even sometimes, right? So maybe have multiple of these source systems, because they might acquire the company and suddenly they have two and they have different definitions for the same thing. So the big task is to align all of these business logics in one place, make them accessible, but also to make it updatable for everyone. So the data that is in the data warehouse should always be a good representation of the real world, as close as you can be, right?
So it sounds like you're leaning towards data quality and how we need to have that as high as possible from the data input to help the process move along.
Yeah, it's also about a data culture, right? If people just consume dashboards and they're wondering, why is this not broken down by country? Well, you need to put in the country for each of your projects in your source system. Otherwise, how should the data? We cannot generate the data from nothing, right? The data has to be somewhere, and it needs to be properly defined and cared for and updated. And this is what I mean with data culture, right? That they can't just expect the data to be right. They need to also put in the work of inputting the data in the right places and keep them up to date.
So we need to take a bit more responsibility on an individual level to understand the data.
Yeah, but I think we as a data team, we can also help them, right? We can have some kind of data quality dashboards where they see where data might be missing in the source systems, and just for example, have this one of these grids, right, with the green and red boxes so that they immediately see where data is missing. And then once they are done with it, all is green and they're happy and we're happy, and we can lead into a bright data future together.
Nice. So data culture, where does that start? Who does that start with?
It should start from the top, right? If the top of the company does not trust the data that they have, then this trickles down to the whole company. right? But from the top, they should, the heads of the company should invest in data quality. They should invest in a data team, set this up, but also convince everyone in the company to do the work of inputting the data, because only with correct data you can make the right decisions. So, but this is a bit tricky to convince people sometimes, because when they don't trust the data, they don't see the value of inputting data in source systems. But this is what you just constantly need to remind the people, that we need good data quality to make good decisions. And it should be an integral part of everyone's job, is to keep the data up to date. And this is what the heads of the company should invest in, and what they should also help the people do that, give them time to do it, right? But also appreciate it when they've done that.
And we've seen that Encavis is from the top very, very passionate about data and data quality. And as the renewable energy industry as a whole moves more towards real-time data, and data quality is a fundamental part of real-time data. But for those who don't know the differences, we have batch and in particular data streaming data. How does real-time differ?
I mean, regarding to our sector, it's very obvious that in the past, the renewable sector could only survive because of subsidies that were handed out, because the technology was so new, right? The technology had to be developed, factories had to be built, so it was very expensive in the past. So it could only happen because of government subsidies. But these days, the renewables are a lot more competitive. They are a lot cheaper than all the other alternatives. They're just not available all the time, right? That's one of the problems. But there are solutions for that. But regarding the sector and the change that we have with the data is that with the subsidies, it was all about how big was your park, kind of, right? It was just how much megawatt does your park have. But now that we are trying to compete with the other energy producers, we need to think more on how we can sell our electricity and really gain a profit out of this. So we need to be a lot more dynamic in when we sell our energy, because in the past it was just we built big parks. But now we have to also sell the energy kind of to the market prices. And what I mean with this is it's called a power purchase agreement, which just tells or states for how much money I will sell my electricity and for how long. And this has been in the past, sometimes for years or even decades. But now this changes into even smaller and smaller time periods. So we might just sell our electricity to this price for the next day or even hour or just minute. And when it comes to these kind of smaller time scales, you need to always have the up-to-date data as fast as possible, right? Because you need to know what the current price of the market is, so you can sell your electricity to the highest bidder. That's essentially what it's about. And in the past, all the renewables, all the data was more like statically, like in Excel sheets available. But now we need to react to the changes faster, right? When we see there's a lot of wind coming, we can sell our electricity for cheaper. But if the forecast tells us that there will not be a lot of energy, that is also valid then for all the other competitors that we see. So we can raise the prices and get a more real price for our electricity.
So this real-time data is critical for renewables. How are we putting that into practice?
Yeah, we need to build this into the infrastructure from the start. This is one of the big factors why we redesigned our infrastructure. to be able to react on changes faster. If there's some shutdown of some big generator, some big power plant, and we need to know about this and react to these changes. And so this is kind of where the human part falls flat. So that's when a dashboard is not enough anymore, right? You cannot have someone look at a dashboard and then when you see in the dashboard that something changes, then do something. This is when you really need to fully automate everything. And this is what we're going towards, right? That's still a bit in the future, but that's where it's all headed to, that these PPAs are made automatically between systems, and not anymore between humans. And this is where the real time really comes show its strength, because you don't need a human anymore. You can just react to the market changes and sell your prices your electricity always to the highest price.
And whose responsibility is it to make sure that these models and predictions are running correctly?
I mean, this is the whole company needs to be on board with that, right? Because the algorithms that you put in place, they need to be well tested. I mean, there are experts for selling electricity, but their expert knowledge needs to be put into code, kind of. And this is always a hard thing to do. But this is what you need if you want to react real time to the market changes. You need to put in the knowledge and all the different data points that they use for their decisions in the past. We need to gather them, keep them always up to date, and then react to these changes and make the right actions, integrating all the different data points that we have.
So it sounds like algorithmic trading almost.
Yes, that's what we're trying to do.
Is there any other industries that you can learn from?
Sure, the finance has been doing this for decades, the whole finance industry, but also marketing does this a lot, right? When you think about the YouTube algorithm, when to put which ad for how much prices, this has also been around for a long time. This is now also what we are looking at and what we are trying to copy.
There's a lot of positives that seem to be present with real-time data. What are the trade-offs, if any?
Yes, I mean, debugging is, I think, really hard. That's easier if you have just if you have your data and then you transform it, and then you can do checks, and everything is kind of statically being able to kind of static, and you can check things in batches, right? Batches, the opposite of streaming. With streaming, it's a lot harder to detect failures, I would say, because and even if you detect a failure, then you need to kind of replay the whole stream from the beginning. Kind of what you do with batches all the time, that you just redo everything. At the streaming, you usually only react to the latest change. But if you have an error in this transformation, then you need to start from the beginning again. And this usually takes a long time, and it's usually a manual process. So this really slows also down your level of innovation, I would say, because if it's running, super great, but if you need to change something, then you need to rerun everything from scratch, and this can have different side effects, and it's not so easy as with batch processing, I would say. And it also is harder to find people that really know real time or streaming systems well. So I think streaming is really great. I love Kafka and everything that is real time, but I think you should use it only when you really have to, because it produces a lot of overhead. So I think if you're doing monthly or even daily reporting, right? If there are humans that consume your data, it's enough if you updated it a couple of times a day. But if there are really like use cases like algorithmic trading, then you really need to react to the data in real time. But really only use real time when you have to is kind of my mantra there.
So only if it don't go run into real-time data if your streaming on a daily basis is adequate, only be turned into real time if it's business critical. And
exactly, don't use real time just because it's cool, but really know that there is a real value in doing something in real time. Only then you should use it. Otherwise, you should stay with batch processing, because it's also a bit cheaper and easier to innovate with it, because you can do changes and data checks and debugging, all those things you can do faster. So what a lot of people do is that they start off with batch, and once they know what the transformations are, then they translate it for streaming architecture.
Okay, but maybe in the future, these tools and these processes will become easier, cheaper, less overheads, and eventually, maybe inevitably, all data will be real time.
Yeah, that would be the perfect world, yes. But I think that's still a long way to go, because you also need a good data quality, right? I think this is where we should go first. Once we have the data quality, and also everything updates regularly and the insights are generated from it, and if that's all going well, then you can think about streaming. It should be the kind of the last step that you do.
We'll call it Data Valhalla for now.
Yes.
Amazing. Well, time has absolutely flown. What a great conversation. So let's wrap it up with a final question and link it in with the last topic. If we were, let's say, a data engineer who sees that the future is real time, in what choices could we make to direct our career into a more real time focused career path?
I think the best technology that people should look into is Kafka, because it's open source. You can really look at the source code if you want to. It's also been around for real time. It's all production ready. It's not that accessible, but there also are some companies that, for example, host Kafka for you, so you don't have to do the hosting part, which is really not that easy with Kafka, because Kafka you always have multiple servers that running together, because it's also a real big data technology. And just the communication between all those different servers is usually really hard. So you should start with a hosted version and play a bit around with the technology, see how it works, to really understand what it does, and not start with it, right? I think you should start really with batch stuff and understand what data really need. And once you're there, you can move into more real-time applications of the knowledge that you have gathered from the batch processing that you've already done.
Nice, good, wise wisdom there. Fantastic. Well, you've taught us a lot today, and we could have gone on for a lot longer. I think these topics lead quite nicely into a future podcast, and we would love to have you on again in the future. But that's all we have time for today. So yeah, thank you very much for your time and your rich insights, Pascal. It's been educational for us all, and topics that I think people wanted to know more about. And it is going to be exciting times for you in the near future as Encavis. Some things to look forward to, and yeah, looking forward to watching those unravel. As always, to the listeners, drop all your questions and feedback into the comment section. We'll pick out some to answer on the future podcasts. Don't forget to like and share so we can get the message out to as many people as possible. But it is bye from us. Thanks again, Pascal.
My pleasure.
And yeah, ciao for now.
Have a good day. Bye.